You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone. My name is Bob Keane. I'm the editor of the international journal Fire Ecology. Fire Ecology is published by Springer, but it is a journal wholly owned by AFE, the Association of Fire Ecologists. And today, this podcast has a very exciting topic to talk about and a very exciting author. We're going to talk about characterizing post-fire delayed tree mortality with remote sensing, sizing up that elephant in the room. I'm very excited to introduce Matt Reilly. Matt, could you introduce yourself and your co-authors, please?
Sure. Thanks, Bob. Thanks for having me, and thanks for listening, folks. My name's Matt Reilly. I work with the Pacific Northwest Research Station and the Forest Service, the Western Wildlands Environmental Threat Assessment Center out of Corvallis, Oregon. And my co-authors, the geospatial wizards behind this, were Aaron Zussman, who's a geospatial analyst, and Yangzi Quan, who works with the Rocky Mountain Research Station.
Well, welcome, Matt. I really appreciate your time and coming and talking to us today. Tell us all about this paper. I'm pretty excited.
Well, so the paper tackles what I call this elephant in the room, where we come up with a new remote sensing method based on your sort of normal remote sensing of burn severity applications and run it out about 5 years to see if we can catch sort of this footprint of delayed mortality through spectral decline in the 5 years following fire. We take 5 fires across Oregon, Washington, California, a pretty good range of biophysical settings, and then we kind of compare rates of delayed mortality among those fires, as well as some of the dominant vegetation types within those fires.
Very interesting. So just exactly what is delayed mortality and why is it so important?
Well, so delayed mortality, it's actually been very, very widely studied in field-based studies of individual tree mortality, where folks go in after a fire and follow the fate of individual trees. And it's really important, of course, that it has a lot to do with post-fire resilience and carbon, wildlife habitat, things like that. But one thing that isn't really known is how widespread it is among fires. Sort of individual-based studies haven't really been able to scale up to start thinking about some of those landscape implications and, how delayed mortality might be important at larger scales.
Yeah, most of the remote sensing studies that we get at Fire Ecology just look at 1-year mortality, and 5-year mortality is so important because of the interactions between insects and diseases. So I was really happy to see this kind of study happen. So how in the heck did you detect delayed mortality? Can you give us a thumbnail sketch of your methods?
Sure. Sort of the quick and dirty was, we took Landsat remote sensing, which is about a 30 by 30 meter pixel, so about the size of a baseball diamond. And we followed individual pixels over time for 5 years out, looking for continued decline in what's called the normalized burn ratio. And to validate it, we were able to find NAPE imagery for immediate post-fire, 3 years post-fire, and 5 years post-fire, and then took a random sample of points across those fires and basically interpreted canopy cover and how it changed over that 5-year time period, and correlated that with the change in MBR. It's a pretty simple method, easy to follow, pretty easy to implement as well.
Yeah, so, and you calibrated this with field data that you got from aerial photos?
Yeah, so we used NAPE imagery to interpret delayed mortality out there in the field, and essentially got NAPE images, pretty fine scale imagery to look at individual tree mortality within that 30-meter pixel. And we looked at canopy cover 1 year, 3 year, and 5 years post-fire, and used that absolute canopy change or the presence or absence of a dead tree to calibrate the remote sensing spectral decline. Yeah, we had pretty decent accuracy. We were able to come up with a single threshold that accounts for some spectral decline, but basically classifies with a much higher accuracy, about 83%, about the presence or absence of delayed mortality. So did it happen or not? And then that actual change in canopy cover is reasonably correlated with spectral decline up to 5 years.
So if we detected the mortality after 1 year and then after 5 years, how much more mortality happens over the 5 years?
It really depends, Bob. I think the most we really ever saw was about 20 to 40% decline in canopy cover. So very rarely did we see, something go from 70% residual canopy to zero canopy cover. So most of it is fairly moderate and somewhat subtle, I would say. A couple trees here and there blinking out.
Okay, well, Matt, what are the implications of the next step for your study?
Well, I think the implications are that we're able to get sort of an expanded look at why delayed mortality is important at larger scales. And I think a couple of the big things that popped out are that our patches of high severity fire generally get bigger. One of the big implications for this is that seeds will have to travel further from residual patches to regenerate. On the flip side of that, we found that low and unburned areas, these are, commonly referred to as fire refugia, sort of very important for landscape resilience and maintaining habitat for late serial species within those fire perimeters. Over the 5-year period, the area of that got cut almost in half, which is a pretty significant decline. And generally speaking, we see that those fire refugia patches shrink quite a bit and become more fragmented. And so potentially, at landscape scales, that's going to affect their function as wildlife habitat, things like that into the future.
Very great. I really appreciate your time coming on and doing this podcast with us, Matt. Have you any funding sources you want to recognize?
Yeah, thanks. This has been part of a Forest Service Washington office study called the Right Seed, Right Place project. And our project, this is just one piece of it, looking at sort of trajectories of post-fire dynamics. I think one of the things we've learned is that growth and recruitment is just one of the processes that's happening out there in post-fire landscapes, and that these landscapes are dynamic, and that delayed tree mortality brings a big part of that. Sort of an interesting new look at how our landscapes are changing over time following fire.
Wonderful. Again, thank you so much for your time. Ladies and gentlemen, if you want to read this very interesting paper, it's available for free at the Fire Ecology website, hosted by Springer. We hope you enjoy the paper. We hope you enjoyed the podcast, and we'll see you next time. Thank you so much.